is Jimmy Song, who I believe doesn't really need an introduction, but in any case, he's been, which is important for this conference, he's been running the Programming in Bitcoin, or well, that's the book, but Programming Blockchain workshops for 5 years now. And Leon is actually one of his alumni, so there is a direct connection to this conference, so it's worth mentioning. He's also just released a new book, which is a bit more political than technical, and it's called Bitcoin and the American Dream. And this is not what we're going to hear about now. We're going to hear about Taproot multisig now. So welcome, Jimmy.
All right, can you guys hear me? All right, great. So the slides are at this URL, so if you are curious about what I'm talking about, then please do that. Go check it out. I'm going to try to hide the top tab. If I can. Yeah, I don't. It doesn't. The function F11 doesn't work on Mac, I guess, or whatever. There's usually like a hide toolbar thing or something, but.
Pull the tab out, or like click on the tab and pull it.
I think that'll just make it like.
No, and then down to the middle.
Yeah, see, it still does that. Yeah, it doesn't actually get rid of the. Whatever. Hopefully you guys can all see it. Yeah, I tried to make the slides good. Anyway, I'm gonna. First of all, it's great to see all of you. I know many of you have been locked down for a couple of years. You know, it's hard, like being alone at home. Now you get to actually meet people in the flesh. So I'm so happy that Leon put this together. So I just want to give him a shout out. Good to see people. You know. Shake hands in person, you know, it feels good, right? And I know we've had that in Austin for like over a year now, but you know, for many of you in Europe, you know, you just got out of lockdowns, you know, I want to acknowledge your pain. All right, so let's talk about Taproot multisig, and that's what we're going to talk about in this in the next 30 minutes or so. But here's what we're going to cover. We're going to just sort of briefly review Taproot and what it does and how it works. We're also going to talk about, start with traditional multisig. How does multisig work now? Then we're going to get to sort of different options that you have with Taproot. And to be fair, I don't think any of these are implemented anywhere really yet. It's up to all of you to go do that. So I'm going to give you some options on what you can do to program multisig in the Taproot world. So single leaf K of N, we'll do multi-leaf K of K, multi-leaf K of K musig, and everything multisig, and we'll talk about degrading multisig. So these are all sort of like different options that we have. There's probably more than this. This is just sort of stuff I've implemented and all the little gotchas and advantages, disadvantages to each, and that's what we'll cover during this talk. So let's get started with a sort of a brief Taproot overview. There's two paths that you can basically go down. You can do a key path spend, so it's locked to a single key. And it requires a Schnorr signature over a point on the elliptic curve, and that's a key path spend. This is what you would call like what used to be the equivalent of kind of like a pub key spend of some kind, a single pub key. And you have a script path spend that requires satisfying a tap script that's embedded in a mass tree or a Merkleized abstract syntax tree. So you can have lots of different options there. The way I describe Taproot is that right now we have two classes of addresses, single key lock and sort of more flexible with script hash or something like that. Taproot essentially joins them both and puts them under one type of address, which is very nice for privacy and so on. Anyway, Taproot tree can have up to 2 to the 128th different tap scripts, so virtually infinite for all practical purposes. The number of different scripts that can be sort of embedded in there. Yeah, I mean, don't like try to make that many because there's no way you're going to be able to roll through a space that big. So That's this is what a Taproot structure looks like. You have a key path spend with the pub key, and that's a single pub key, and you have the mass tree on the right side. This is a script path spend, and you have different tap scripts that sort of come up to Merkle root, which we call the tweak, and then the tweak pub key is what you publish as part of the script pub key. This is where you spend too, this tweak pub key. And as long as you know the tweak and you have the private key to the public key, then you can do the key path spend. And if you can satisfy any of the tap scripts and you have the pub key, that's enough to do the script path spend. So that's basically how it works. And this is an example of 3 different tap scripts that you can spend out of. But this is generally how Taproot works. You have multiple options on how you spend. All right, so let's talk about traditional multisig script, and this is what that looks like. Typically, you have some sort of script pub key, usually it's hashed or something like that, but you could also do bare multisig, I guess. And it's something like opt2, pub key A, pub key B, pub key C, opt3, opt check multisig. So all the examples today on my slides are going to be 2 of 3 multisig. So you have 3 pub keys. You have to have 2 signatures out of them. The script sig needs to be opt0, signature for one of the keys, signature for another one of the keys. And you have this execution stack or whatever that we're going to actually go through. And the execution looks something like this. You have a whole bunch of stuff. All of these things on the left will put stuff on the stack, except for the last one, which will actually do something to the entire stack. And it's a giant opcode, opcheck multisig. It consumes one more element than it's supposed to, which is why you need that 0 at the bottom. It's a famous off by 1 bug. And if 2 of those signatures are good for 3 of these pub keys, then you're done. It's a valid script, and you are good to go. Now, the traditional multisig has some advantages and disadvantages. The nice advantages are that it's non-interactive, right? Stepan just talked about all the problems with interactivity. You don't have any interactivity here. You just go and collect them, collect signatures from different parties, and you're good. Also, signers can be determined as you go. So you have, say, 3 pub keys. If A is not available, you can just go to B and C and collect their signatures instead, and you're good. But you don't have to determine who's going to sign or anything like that. That said, all the unlocking conditions are revealed in traditional multisig, and it could be, if you have custom multisig, like 2 of 3 of these or 5 of 7 of these or something like that. All of the conditions are revealed, and that kind of sucks. Also, all of the public keys are identified. That's part of the protocol. Even if B isn't signing, like in the example, you reveal B's pub key, and that way, the attacker kind of knows something about you. And finally, it's large fees. B didn't sign, but you still have to reveal the public key, right? And that's additional cost in terms of fees because it makes the transaction bigger. So those are some advantages, disadvantages of the traditional multisig. Let's start talking about what we can do in Taproot. This is the single leaf multisig Taproot. And this is about as close to traditional multisig as you're going to get in Taproot. And the idea here is that you have a tweak public key. Usually the key path spend is going to be 3 of 3 musig or something like that. So you have a single pub key that you can use. But the tap script is going to be something like 2 of 3 tap script. And I'll describe that shortly. But it's, there's no complicated mass tree. It's just really one script on the script path side, and that's it. So what does that look like? It's something like a K of n tap script is how I would characterize it. But this is 2 of 3, and the tap script looks something like this. You have pub key A, opt check sig, pub key B, opt check sig add, which is a new opcode as part of Taproot. pub key C, op check sig add, op2, and op num equal. So this is sort of like the recommended way to do K of n. The witness is going to have two signatures and a blank in the middle. The blank in the middle sort of indicates I don't have a signature for this particular one. And the reason for that should be obvious in a second, but you have this set of commands that you need to execute. And here's what that looks like. You have a bunch of stuff at the top that's just going to go straight to the stack. And the first operation that's going to execute is op check sig. You take pub key A for signature A. You consume those two elements, and if it's a valid one, then you put a 1 there. If it's invalid, you put a 0 there. So we're supposing that it's valid, so we put a 1 there. Then pub key B goes on the stack, and we get op check sig add. And op check sig add is interesting. The way op check sig add works is that it consumes 3 elements: a pub key, a number, and a signature, and it only increments the number if the signature is good for that pub key. Now, in our case right now, if you look at the top 3 elements, the signature is actually blank. So it's not a valid signature for that pub key. So it doesn't actually increment the number. It'll just leave a 1 afterwards, like so. So you have 1 and signature for C at this point. Pub key C goes on top of the stack, and we have op check sig add. At this point, it looks at the signature and the public key. And if it's going to be valid, so instead of 1, it's going to increment it to 2 because it's a valid signature. So you're adding, incrementing or accumulating signatures. And we'll have a 2 there. Op2 is going to put 2 on top, and op num equal will check that the top 2 are equal, and you have a 1, and you have valid execution. So this is how a single leaf K of n multisig would look like. Now, there are some advantages, disadvantages to this. First, this is still non-interactive, and that's a very good thing. You don't need to go back and forth between different signers or whatever. It's also, the signers can be determined as you go. So you don't have to go say, okay, A and C are signing. If A is not available, you go to B instead and still get whatever it is that you need. That said, all unlocking conditions are revealed, mostly because you have that one single leaf, and it's obvious when you see on chain that it is a single leaf. The public keys are still identifiable because you reveal A, B, and C as part of revealing it. So if you happen to know who B is, then you can go and try to threaten them or something. You don't want to reveal additional information if you can help it. Also, it's like larger fees because you have to reveal every public key. So if it's like 5 of 9 or something like that, you reveal all 9 public keys. So the 4 keys that didn't sign anything, you still have to reveal. Goes on chain, that's a lot more bytes. It means larger fees. But so you can see that the advantages, disadvantages are very similar to traditional multisig. Now, what are our other options? Well, we can do something like multi-leaf K of K tap script. So what does that mean? Well, imagine something like this. This would be the Taproot structure. You have 3 of 3 musig, which most of the time isn't going to be used, I guess. But on the right side, you have 3 tap leaf or tap scripts that sort of get accumulated to that tweak. And it's every combination of 2 of 2 out of the 3 keys. So this is A and B, A and C, B and C. And they're all available as tap scripts. And instead, each one will have a tap script like so. This would be for A and C. And the witness will require those 2 particular signatures. And the execution is going to be very similar, except all of the, you need to essentially provide valid signatures for each one. You're not really, quote unquote, wasting any space because you don't reveal pub keys that you don't have signatures for at all. So, we can go through this, but you basically do op check sig, that'll give you a 1, and then the pub key C, op check sig add, that'll, increment the 1 to a 2. and op num equal, you're good. You have a valid unlocking of that particular tap script. So here's some multi-leaf advantages and disadvantages. The main advantage is still that it's non-interactive, right? You're not forced to go and trade nonces or anything like that. But you do have to determine who the signers are beforehand. So if you are doing, if A and B are signing, then you need to choose that particular tap script at the beginning before everything, and then bring that particular transaction over to whoever is signing. So, and if what happened here? Okay, and if somebody isn't available, now you have to start over again. And you can imagine if it's like 4 of 7 or something like that, and you've already got 3 signatures, and the 4th person isn't available. That sucks, right? Like, because you have to start from the beginning and go through the entire process again. So that kind of sucks. That said, only one unlocking condition is revealed. So there could be like, for something like 3 of 5, there's like 10 different conditions, right? That's the 3 choose 5 ends up being, or 5 choose 3 ends up being 10 different combinations. You only reveal that one unlocking condition, and it's sort of minimal. You're only revealing the pub keys that have signatures and not any of the other pub keys. And that's I mean, it's still identifiable, the ones that sign, but it's not quite as bad as before because you're not revealing everybody's. Smaller fees because you don't have to reveal all those private public keys that you're not signing with. So that's kind of nice, right? Like especially for very large multi-sig setups, you could have lots of different public keys, and you don't have to reveal any of them or put them on chain, and therefore you're going to get generally smaller fees at least than the other one. So that is multi-leaf KFK multisig. We can also do multi-leaf musig tap script, and this looks something like this. It's very similar to the other one, except instead of leaves that use the op check sig add construction, you have musig. So you have aggregated public keys for each of them. I don't know why this keeps. Yeah. I apologize. I don't know what's going on. All right, so you have 2 of 2 musig for each of the combinations of pub keys. So you might have A plus B, A plus C, B plus C as the 3 different musig things. So then it becomes kind of trivial for each tap script because it's the public key of A and B. Op check sig is your tap script, and the witness is just a single signature, which is aggregated, and you have to generate it kind of together in an interactive way. But the execution looks like that, and it's pretty simple. It's checking that one particular signature being valid, and you're good. The advantage, disadvantage of multi-leaf musig is that it is interactive. This isn't, say, a problem if you're doing something like Lightning where you're like doing a lot of communication anyway. But for any sort of like secure multi-sig setup, like having to go back and forth, even in 2 rounds, kind of sucks. And I think Stepan pointed out a lot of the different like problems that you might encounter. A lot of hardware wallets, for example, aren't used to keeping state, things like that. So interactivity is a major drawback. Also, the signers have to be determined beforehand. This is absolutely critical part of musig, is that you need to know who the group is. And you, again, if one of the parties is unavailable, you're kind of screwed. That said, there are some advantages. Only one unlocking condition is revealed. And furthermore, you're not even revealing your public keys, because the aggregated pub key, if you know the pub keys that are going into it, then you can go in that direction and figure out the aggregated pub key. But if you just know the aggregated pub key, you can't derive the component pub keys that went into it. So like really you have no idea who signed it or what happened or anything. So it gives you a lot more privacy with respect to what you're actually revealing. And of course, this has the smallest fees because you're only revealing one pub key and one signature, no matter what the combination is. So practically speaking, this ends up being very nice because you're kind of saving money on chain. You get a lot of privacy. The problem though is that interactivity and having to it costs you more to go and do it, and whether or not that's worth the privacy and on-chain less fees is kind of up to you. All right, so those are sort of our three different ways that you can do multi-sig within Taproot. But there's one other one that I want to point out that you can do, which is multi-leaf everything. And the idea here is that with Taproot, you can just sort of like add everything, right? Like you can just sort of throw them in there because it doesn't really cost you that much other than like more levels of, you just adding a level doubles the number of tap scripts you can have basically. So what you can do and I didn't put the key path spend, but basically this would be the script path. You can have 2 of 2, a K of K multisig. So these would be the tap scripts that are 2 of 2. You can have 3 of them. You can have 3 musig ones, and you can have the 2 of 3 K of N. So you can have all of them thrown in there, and you just pick whatever it is that you need as you go. And the beautiful thing about this is for all of these, like you can just sort of like, okay, well, you can do one or the other, whatever it is that you want. And if you happen to have all of the keys nearby, then maybe you optimize for privacy and fees. If you don't, then okay, do I know who's going to sign, who's available? Then, like you could figure out what the trade-offs are on your own. But of course, like I don't know if you want to be doing that necessarily. It puts a lot of pressure on whoever's coordinating the whole thing. But it's kind of nice that we have this option as part of Taproot because really it's very, very cheap to throw more scripts in there because it's ultimately a Merkleized abstract syntax tree. All right, finally, I want to, this one is a little bit more orthogonal to all of the other ones, but you can have degrading multisig tap script, and this is kind of an interesting concept. And without lots of generality, this is what I'm going to show you, is you can have like 3, on the tap script spend side, you can have something like 2 of 3, and then after some time lock, 1 of 3. And you can imagine if it's like 3 of 5, then after some time 2 of 5, after even more time 1 of 5, something like that. And you can have all of those branches. It doesn't have to be 2 of 3 there. You can have 3 leaves off of there that are 2 of 2 each, and it could be musig or it can be, it could be whatever. Just the idea that you have this option of a time lock multisig that sort of like degrades gracefully. And yeah, like basically the actual time locked K-1 of N tap script looks something like this. And this is the 1 of 3 case. Essentially, you use something like opcsv to say, okay, after a year, and this is only valid after a year of it being on chain. And the rest of it goes through the same way. And if you have a valid signature from one of the keys after a year, then this would work. The nice thing about degrading multisig is that you get backup in case of key loss. So somebody loses it or something like that. The other really nice thing about degrading multisig is it's kind of like built-in inheritance or estate planning. So this is, of course, for a lot of Bitcoiners, like something that you think about. Okay, what happens if I die, and how am I going to make sure that people, my loved ones get the Bitcoin, and it doesn't just sort of get donated to the rest of the Bitcoin community via, like never being able to spend it again. And that's through using something like gracefully degrading multisig or having a backup or something like that. It is kind of nice that we get these advantages, and you can, again, because of the way Taproot works, you could just sort of throw it in there as one of the conditions, or 100 conditions that are similar like this. The major disadvantage is that the funds have to be moved before the time lock, or else they can take it away from you. Of course, you might have security by obscurity. They don't know that they're part of the backup or something like that, in which case then maybe you can get away with it. But generally, you're going to want to move it on a consistent basis depending on when that is. That kind of sucks because that's going to cost you money, but hey. Anyway, those are it, and these are my places that you can contact me: Twitter, GitHub, Medium, Substack, and you can, I think, still see the URL in the upper corner, jimmysong.github.io/taproot-multisig if you want to go and take a look at it. But I don't know how much time I have for questions. Yeah. Anyway, thank you. All right. Any questions? You got two over here.
Question is just size-wise, because if it goes down the TypeScript path, you have to reveal the internal key and then the inclusion proofs and everything. Did you run some numbers? What size of the script it starts to become beneficial fee-wise? Yeah,
so it turns out like each level of the TypeScript is 32 byte additional hash, right? So because of the SegWit discount or whatever, it ends up that's 8 more bytes for the purposes of calculation. Each pub key is also 32 bytes, so that ends up being about 8 bytes as well. So roughly speaking, like if each level per pub key, that ends up being about sort of like the equilibrium there. So if you have more than one pub key and you only go down one level, then it might make sense. But yeah, you can run the math on that, but yeah, it ends up being like, depending on how much you want to do and what the probability of using that particular path is, you can optimize based on that, which is kind of why I put the 2 of 3 sort of up one level, because that's the most flexible, most likely to be used, and also it's the most costly, so you want to reduce the spending on that and sort of balance it out. But it depends on your use case, obviously. I think he had a question. Yeah.
So the question about the music in different branches. So can you scroll to the diagram where you have all musics?
Yeah, there you go.
So I think that does it make sense then to make it 2 of 2 music in the pub key, in the key span, and then you have a flat 2 other 2 of 2 musics on the
that's definitely an option. And you if you know like A and B are going to be more available, it's going to be cheaper to do the key path spend. So that's definitely another way to do this particular one. Yeah.
Thanks.
One more?
Yeah.
So my understanding is that what we got in the Taproot upgrade was like one set of things, but there's still kind of maybe some other future upgrades. I don't know if it's MAST or SIG-AG. Do you know enough to, what's the jump from what you just presented to those potential future upgrades? What can't be done? Does it seem like we have all this right now, or are there some missing pieces?
Well, so nobody's actually implemented a lot of this, right? So especially hardware wallets and stuff like that. A lot of them are, we've been talking to them about, okay, how are we going to do multisig in a Taproot world? And they're like, okay, well, we want to do the easiest thing, which I think is single leaf multisig, because that's as close to the traditional multisig. They don't want to think about all the other ones. But I think we need to get some of these other things in there and make it kind of a standard. I would love to see like an everything multisig be standard, and then assign the various things as you need and so on. A lot of the capabilities are there to be coded, but really it's up to you guys. Really, this is a developer conference. Whoever is working on a wallet, go and make this, because we want to see, or at least like very selfishly, I want to be able to secure things this way, right? Like have all these different options, and like as a coder, like implementing this for my library for Biddle, like it's great because it's very forgiving for developers, because you can completely screw up one of the branches of the TapScript, and it doesn't matter. The other ones are completely independent of it, as long as you have the hashes or whatever. You can just sort of reveal and still spend on that particular TapScript path or the key spend path. I just want more experimentation in this area. I don't know necessarily what the best UI is or what the best UX is, but let's get some more options out there, because we got some really nice capabilities. All right.
Thank you, Jimmy Song.